Hello! In this video, we're going to take a look at electrical connections between the LS3's wiring harness and the rest of the car, including connections to gauges, the transmission, and the battery. To keep the wiring in Dylan's 1980 Camaro straight, I drew this schematic. It only shows the connections between the major electrical systems on the car, which is why I call it a supplemental schematic. Check out the description below if you would like a free copy. On page 1, notice the engine harness user outputs bulkhead connector. Pin C is an output representing engine speed. We connected it to the TAC input of our VHX gauges and the TAC input to our MSD Atomic transmission controller. Because the engine speed output is 2 pulses per revolution, we had to configure both the VHX gauges and MSD transmission controller to think they are connected to a 4-cylinder engine. Pin J of the user outputs bulkhead connector is throttle position. We connected it to the TPS input of the Atomic transmission controller. TPS stands for throttle position sensor. Pin M of the user outputs bulkhead connector is engine ground. We connected it to the TPS ground reference input of the Atomic transmission controller. MIL stands for malfunction indicator lamp, aka service engine soon. It's a single wire that crosses the firewall through the same hole as the electronic gas pedal wiring. We connected it to the check engine input of our VHX gauges. Turning to page 2, notice the modified engine fuse relay box. Run fans is an input that we added to the fuse box. It is connected to the AC system's Trinary safety switch, which pulls the signal low to turn on the fans when the pressure in the system is higher than its trip point. An output of the fuse relay box is fuel pump power. Notice how the wire connected to the fuse relay box has a little /1.7a tacked on the end. That means the signal is continued on page 1, where gray fuel pump power is attached to plus 12 volt power, pin C of the fuel pump connector. Back on page 2, the next output of the fuse relay box is fan 1 power. It's a light blue 10 gauge wire that runs to a radiator cooling fan. Another video showed how we added a second relay to create fan 2 power. Light blue fan 2 power is connected to a second radiator cooling fan. The last output of the modified fuse relay box is AC power. It supplies fused, always available 12 volts to 2 power inputs of the vintage air wiring harness. There's another wire that crosses the firewall through the same hole as the electronic gas pedal wires, a pink wire called engine harness ignition switch. This is an input to the fuse relay box that must be powered when the ignition switch is on, including while the engine is cranking. The coil ignition wire of the Painless performance wiring harness behaves exactly this way. Leaving the schematic, there are a few more connections that I want to cover. The first is an input to the engine wiring harness called VSS, Vehicle Speed Sensor. The harness includes a 2-pin connector that would plug right into the speed sensor at the rear of our 4L70E transmission. But we had a problem. The transmission controller also wanted to plug into the same connector. We solved this with a splitter so that both harnesses could connect to VSS. So far it's working perfectly. Both the engine computer and transmission controller are happy. The engine harness includes an alternator control connector. Its use is optional. The car's Painless performance wiring harness also included alternator control wires, so we had to choose which alternator control to use. We figured that if anything ought to know when to enable the alternator, the engine computer should, so we used the engine harness's alternator control. The LS3's instructions say to connect battery power to one of the 3 studs on the fuse relay center using at least 8 gauge wire. This makes it sound like it doesn't matter which post you connect to, but is that true? Nope. It matters. Here's a picture of the fuse relay box. The posts they are talking about are here, here, and here. Based on measuring the voltage on these posts with and without the red 50 amp fuses installed, here is how they're connected internally. The post on the left is directly connected to the maxi fuse pins as shown. The post on the right is connected through a 50 amp fuse. The middle post is also connected through a 50 amp fuse. So what? Well, if we connected battery power to the middle or right post, and the fuel pump, fans, AC, and engine combined draw more than 50 amps, a fuse will blow. But with the battery connected to the left post and everything else the same, there won't be a problem. So, we connected the battery and alternator output to the left post. Last, but possibly most important, the engine needs to be grounded. This is the ground strap we installed from the engine to the chassis. Only inches away, a big cable connects the chassis to battery ground. Now that we've covered the connections between the engine wiring harness and everything else, you probably have some questions, like, okay, I want to use the TPS output of the user outputs bulkhead connector. How do I do that exactly? The answer, and many other helpful bits of information, will be covered in another video. Comments and questions are always welcome, and they help other viewers. Thank you for watching.
May I have